Hello everyone, welcome to today's lecture on Introduction to HVAC System and Energy Efficient Heating Options. My name is Lakshman and I am thrilled to guide you through this exploration of energy efficient building. In the previous lecture module, we have already learned about number 1, transition existing building to net zero energy, strategies for energy conservation and optimization in retrofits, case studies of successful energy retrofits, retrofitting in strategies for improving building envelope efficiency, materials and technology for energy efficient retrofit, and introduction to active energy retrofit technologies, integration of renewable energy system in retrofit, and also some case studies showing successful active energy retrofit project. So in this lecture we will start a new module on HVAC system and energy efficient heating options. In this module, we will learn about first, introduction of HVAC system, second, components of HVAC system, third, heating, ventilation and air conditioning principles, energy efficiency consideration in HVAC design, fifth, comparison of heating options, efficiency rating and consideration for heating systems. Next, we will learn about strategies for optimizing heating system. So, this is the basic core things which we will cover in this lecture. The outline of this lecture will be as follows. First, we will get the introduction of various HVAC systems and its different components. Then, we will learn principle of heating, ventilation and air conditioning. Then, we will start with energy efficiency consideration in HVAC design, its load calculation, high efficiency optimization system design, building envelope and outdoor air management. Then, we will study the comparison of heating option in HVAC. Next, we will learn about efficiency rating system and consideration for heating systems. We will also learn about the strategies for optimizing heating system efficiency. And then we will conclude with the brief summary of what we have learned in this lecture. So, I will start with introduction to HVAC. So, what is HVAC? HVAC stands for heating, ventilation and air conditioning. These systems work together to create a comfortable and healthy indoor environment. Heating, it keeps you warm during weather by generating heat and distributing it through your building. Ventilation, it ensures fresh air circulation by bringing in fresh outdoor air and removing stale indoor air. This helps in maintaining a good air quality and prevents stiffness. Now, air conditioning. Air conditioning cools you down during hot weather by removing heat from indoor air and releasing it outside. It also controls humidity level for adding comfort. Next slide. In this slide, we will learn about the use of HVAC. HVAC system keeps us comfortable and healthy. They can raise or lower our temperature. Managing humidity and filter air, removing dust are some of its function. By circulating air and bringing in fresh air, they prevent stagnation and control contamination. This all work together to maintain a clean and comfortable indoor environment. In next slide, this is about application of HVAC. So, where all we can use HVAC? First, we can use HVAC systems in our residence, that is residential use. HVAC systems are essential for maintaining thermal comfort and indoor air quality. They keep us warm in winter and cool in summer, ensuring a comfortable living environment. Then we can also use HVAC system in our commercial complex like commercial building. HVAC systems are crucial in commercial buildings such as offices, malls, storage and stores. They create a comfortable environment for employees and customers which can improve productivity and their sale. Third is industrial use. HVAC systems are necessary in industrial facility to maintain a proper condition for manufacturing processes. They can control temperature, humidity and air quality to ensure product quality and safety for worker. Then fourth is educational. HVAC system provide a comfortable learning environment for students and teachers in school and university. Proper ventilation helps to improve air quality and concentration. The last point is pharmaceuticals. HVAC system is also vital in pharmaceutical industry to maintain a strict temperature and humidity control for storing and manufacturing of drugs. This helps to ensure the potency and sterility of medication. HVAC systems are also used in hospital, it play a critical role in maintaining the environment for patients care. For patient care, they help to prevent the spread of airborne diseases by controlling the temperature. HVAC systems are also used in malls. HVAC systems are essential in malls to create a comfortable environment for the workers and the customer. They help to regulate the temperature and air quality, which can improve morale and focus. Next slide. In this slide, we will learn about the component of HVACs. There are various components of HVACs. For example, thermostat, furnace for heating, heating pump which is used both for heating and cooling, air handler, ductwork, ventilation system, humidifier and dehumidifier. Next slide, we will learn in detail about the component of HVAC. First, thermostat. The function of thermostat is it act as the control center, allowing you to set and regulate your desired indoor temperature. When you prefer a cozy retreat in winter or a cool haven in summer, the thermostat put you in control. Now we will learn about the importance of thermostat. The importance of thermostat is that it enables the precise temperature control and energy efficiency by signaling the HVAC system to heat or cool based on user setting. Now, second is furnace for heating. We generally use furnace for heating purpose, and its function is to generate heat using fuel, and the kind of fuel it uses are generally gases, oil or electricity or any other energy sources which can generate energy. One of the component of furnace are heat exchanger. The purpose of heat exchanger is it transfer heat from the combustion process to the air without mixing combustion gases with indoor air. Importance of heat exchanger is it provide warmth during cold weather by circulating heated air throughout the building. Next slide. Again about the component, and the component is heat pump. So the purpose of or the function of heat pump is to transfer heat between indoor and outdoor environment using refrigerant cycle. Importance of heat pump is that it provides both heating and cooling function essentially by moving heat rather than generating it. Now there are various components of heat pumps. Some major component of heat pumps are evaporator coil, condenser coil, reversing valve, expansion valve, indoor fan, outdoor fan. What is evaporator coil? It absorbs heat from indoor air as refrigerant evaporate inside. The coil during the heating mode, condenser coil. It releases heat to the outside environment during cooling mode, causing refrigerant to condense back into the liquid. Reversing valve. In heating mode, the reversing valve changes the direction of refrigerant flow in the system. Now next is expansion valve. The expansion valve reduces the pressure of the refrigerant liquid before it enters the evaporator coil. This decreases in pressure, allowing the refrigerant to absorb heat more easily. Next component is indoor fan. An indoor fan circulates air over the evaporator coil, drawing warm air from living space and blowing cool air back into the room. Next is the outdoor fan. An outdoor fan circulates air over the condenser coil, having to remove heat from the refrigerant and release it to the outside air. Now next is slide number 12. It's again about the component which we are going to discuss in slide 12 is air handler. The function of air handler is to distribute conditioned air throughout the building. It ensures proper air circulation and filtration for maintaining indoor air quality and comfort. There are various components of this, and some of the major components are: first is blower fan, which move air through the ductwork. Second is filter. It cleans the air by trapping dust, pollen and other particles. So filter does not allow the outside dust to enter the room, and it send the air which is clean. It does not send us the impure air. It purifies the air, then send us to us, so that we can get a good and pure air. Next is ductwork. The function of ductwork is it channels heated or cooled air from HVAC system to different room and spaces within the building. Its importance is it facilitates the distribution of conditioned air while ensuring even temperature throughout the buildings. The next slide is about component of HVAC, that is humidifier and dehumidifier. This ventilation system is, it brings in fresh outdoor air and exhaust stall indoor air. It also maintains indoor quality by diluting pollutant, controlling humidity and providing fresh air circulation. Component of ventilation systems are air intake vents. It allows outside air to enter the building. Exhaust fan, it removes indoor air containing pollutant and excess moisture. Now we will learn about humidifier and dehumidifier. Function of humidifier and dehumidifier is to adjust indoor humidity level as needed. Importance of humidifier is that it adds moisture to dry air during heating, and importance of dehumidifier is it removes excess moisture during cooling to prevent mold growth and maintain comfort. So the function of humidifier and dehumidifier is that they maintain the humidity level inside our house. If there is too much dry air inside our room, then we use humidifier which add moisture in it, and if there is excess of cold air, then we use dehumidifier because it will help in preventing the mold growth, and it will also help in maintain the room temperature, and it will help in maintaining a comfort in the room. So in next slide we will learn about the principles, HVAC principle. Heating, ventilation and air conditioning HVAC system are designed to control indoor temperature, humidity and air quality to create comfortable and healthy environment. First, we will see some heating principles. Following are the heating principle. Number 1, heat generation. Heating system use various energy sources, example gas, electricity, oil to generate heat. Next point, common heating method include furnaces, heat pumps, boiler and electric heaters. Second is heat transfer. In heat transfer, heat is transferred from the heat sources to the indoor air via conduction, convection or radiation. The heated air is then distributed throughout the building using ductwork or radiant heating system. Third is temperature control. In temperature control, thermostat monitor indoors temperature and activate heating system to maintain desired comfort level. Efficient heating system optimize energy use while ensuring consistent warmth. Now we will see ventilation principle. Earlier we saw heating principle, we learned about heating principle. Now in this slide we will learn about the ventilation principle, the principle of ventilation. So the first principle of ventilation is air exchange. Before learning about it, let me tell you, the ventilation is one of the most important process or one of the most important principle one should keep in mind while designing any room, any house or any space, because through ventilation a proper movement of air take place. So like I said, a proper movement of air take place, it means that the cold air or the air which is comfortable for us, that is the outside air, it flows in through a window inside a room and it replaces the warm air of the room so that we can get the fresh air of outside. The first point of principle of ventilation is air exchange. Ventilation system bring fresh outside air into the building while exhausting stale indoor air. This continuous air exchange dilute indoor pollutant including volatile organic component and carbon dioxide and also some airborne particles. Second is air filtration. Filters within ventilation system capture dust, pollen, mold, spores and other contamination, also improve the indoor air quality. High efficiency particulate air filters are effective at removing the particle. Now the third point is air distribution. Ductwork and air handler distribution ventilated air evenly throughout the building. Proper air distribution ensure consistent air flow and comfort in all areas. So this was the principle of ventilation. So the ventilation principle is very important, and it is very important for our also our day-to-day life. Every room or every house, every space should have a proper ventilation in it, because without any proper ventilation we cannot have a proper air movement. So if we do not have a proper air movement, so we cannot get fresh air inside our room. In next slide we will learn about the principle of HVAC, that is air conditioning principle. So in this slide we will see air conditioning principles, and they are: first air conditioning principle is heat removal. So everyone know what is air conditioning, that is AC. So we generally use AC in hot weather or in summer or during humidity. If we are feeling humid or our surrounding temperature is high, so we use AC, that is air conditioning, to make our room temperature comfortable for us, to lowering our room temperature. Air conditioning help in maintaining our room temperature, that is if the outside temperature is more than 35 degree, and if we use AC, room temperature will come down. It will maintain the temperature of the room in which AC is being used. So the first principle of air conditioning is heat removal. Air conditioning system remove heat from indoor air to lower temperature. This is achieved through the refrigeration cycle, where refrigerant absorb heat from indoor air at the evaporator coil. Second principle is humidity control. Air conditioner dehumidify indoor air by condensing moisture on the evaporator coil. The next point is controlling humidity level, enhance comfort and prevent mold growth. Then the third point is cool air distribution. Cool air is distributed through ductwork or air handler to maintain desired indoor temperature. Next point is proper insulation and sealing of duct optimize cooling efficiency. Now we will go in our next slide, which is energy efficiency consideration in HVAC design. So energy efficiency is a critical factor in HVAC design. As we all know, HVAC stands for heating, ventilation and air conditioning. Energy efficiency aims to optimize system performance while minimizing energy consumption and operating cost. Creating an energy efficiency HVAC system starts at the design stage. Here are some key considerations. So first is building envelope. So in building envelope there are three things which we should keep in mind. First is what is building envelope, that we will study, and first point under building envelope is air tightness. A leaky building makes HVAC system work overtime to keep temperature steady. Plugging air leaks saves big on energy bills. Next point is insulation. Good insulation in wall, ceiling and attics cut down heat moving around. This takes stress off heating and cooling unit. Insulation of wall and ceiling means it does not allow the air inside the room to travel outside, or it does not allow the air of outside. Example, if we are living in a cold place, so if we have good insulation in our wall, in our ceiling, then it will not allow the cool air of outside to enter our house. Same, it will also not allow the warm air of our house to go outside. So this will create a good and healthy and comfortable environment inside our house. Third point is window picks. Windows that save energy have special low coatings. This help keep heat out in summer and during winters. Now the second point is, which comes under energy efficiency consideration, is equipment selection. So before selecting any equipment, we should check various things, like it should be energy smart, it should have speed changing gear, it should be perfectly fit for our house and in our budgets. So First is energy smart system. Pick furnaces, boilers, heat pumps and AC unit with top AFUE or SEER scores. Next point is speed changing gear. Fan and compressor with speed changing motors torque their pace to match need, cutting power use versus fixed speed setups. Perfect fit. Too big equipment flicks on and off more often, wasting more time and energy. Go for the system that match your building exact need. So before selecting any equipment, we should first check about its energy smart system. Then about speed changing gear is important, because if we have purchased any fan or compressor with speed changing gear, the motor will torque their pace to match our need, and it will also help in cutting the power use. The third point under energy efficiency consideration is system design. Under system design, first point is ductwork design. Well sized and sealed duct cut down on energy waste when moving air around. Shorter duct run and insulation in unconditioned area make a big difference. So first point is duct design. Second point is zone control. Building splits into zone with their own thermostat, heat or cool only the space people use. So in this, the thermostat will heat or cool only that place, the place which people are using, or where the place which is being occupied. Okay, it will not use the place which is no one is using. Or next point is ventilation strategies. Natural airflow can step in for mechanical system when the chances arise. Operation and maintenance. Regular maintenance. First point under this is regular maintenance. Regular cleaning and maintaining of HVAC equipment ensure optimal performance and efficiency. So we should try to keep and maintain our system, and we should try to clean it regularly and maintain it regularly as much as we can do, as much as it is possible for us to do. Next point is air filter changes. Dirty air filter restrict airflow and reduce system efficiency. Replace air filter regularly according to manufacturer requirement. The third point is occupant behavior. Educate occupant on adjusting thermostats, opening window for natural ventilation, and minimizing heat generating activities to promote energy saving. Now we will go in our next slide, which is comparison of heating option in HVAC. In this slide, we will study various heating options and their comparison in HVAC. So our first is furnace. In this, one type of heating system are used in HVAC. It uses natural gas, propane or oil to burn fuel and heat a metal heat exchanger. Hot air is then circulated throughout the house using a network of ducts and vents. Now we will learn about the advantage and disadvantage of furnaces. Some of the advantage of furnaces are: it is effective and suitable for cold climate. Second is less cleaning is required and can be used with central air condition for a combined system. Now the disadvantages: it uses flammable fuels, fan and ducts can spread the dust which is present. Now in next slide we will learn about the boilers. This come under the same comparison of heating options. In boiler, it also uses natural gas such as propane, fuel oil or electricity to heat water in a central boiler. This hot water is then circulated through pipes to radiator, baseboard heater or radiant floors system throughout the house. Transferring heat to the rooms is one of its uses. Now some advantages of boiler. First is it offers precise temperature control. It is ideal for cold climate. Second is can be zoned for heating different areas of house independently. Third, no ducts required, potentially reducing dust circulation compared to forced air system. Now some disadvantage. First is it requires installation of pipes and radiators which can be expensive. Second is maintenance need may be higher compared to furnaces. Now we will go in our next slide, which is about heat pumps. Heat pump moves heat from a cooler area, for an example outdoors, to a warmer area, that is indoor, using electricity, and can also reverse the process for cooling in the summer. Some pros and cons of heat pumps are: they are environmental friendly as it transfers heat rather than generating it. Also, it can function for both heating and cooling, reducing the need of separate system. Next, lower running costs compared to electric furnace in moderate climate. Some cons of pumps are: it may not be effective in extremely cold climate where there are less heat to transfer from the outdoor. Initial installation can be high. Next slide is comparison of heating option in HVAC. In this slide, we will discuss about geothermal systems. It utilizes the earth constant temperature to heat and cool your home. A loop of underground pipes circulate water that absorb heat from the earth in winter and transfer heat back into the earth in the summer. A heat pump extracts this heat or transfer it to your house as needed. Some of its advantages are highly energy efficient and environmental friendly, can be used in both heating and cooling. Some of its disadvantages are very high initial installation costs due to ground loop drilling, and it is also not suitable for all location. Now, comparison of heating option in HVAC. Next we will discuss in this is radiant heating. Radiant heating system are electric cable, water pipe or mats assembled beneath the floor, wall or ceiling to directly warm objects in the room. The warmth radiates from these objects, heating the space evenly and comfortably. Advantage are very comfortable and silent operation, provide even heat distribution throughout the rooms. Disadvantages are installation can be complex and expensive. Floor heating may not be suitable for all types of flooring materials. Now we will learn about the comparison of heating option in HVAC. SEER. What is SEER? SEER is a seasonal energy efficiency ratio for heat pumps. This ratio measures the heating output of a heat pump compared to electrical energy it consumes. Higher SEER rating indicate better efficiency in heating model. Now we will learn about EER rating. EER rating is used for comparing efficiency of room. Now HFPF rating. HSPF is heating seasonal performance factor for heat pump. Similar to SEER, HF, that is SEER, HSPF specifically measure the heating efficiency of a heat pump throughout a typical heating season. Next is AFUE, annual fuel utilization efficiency for furnaces and boiler. This percentage indicate how efficiently a system convert fuel into usable heat. High AFUE rating signify better efficiency. Example, a 95% AUFE furnace uses 95% of the fuel of heating and loss only 5% to exhaust. Next slide is comparison of heating option in HVAC. When choosing an efficient heating system, there are several important factors to consider. First is climate. Local climate play a significant role in determining the most efficient heating system for your house. In very cold region, furnaces and boiler tend to be more efficient. They can handle extreme cold weather and temperature effectively. Second is fuel cost. Research the cost stability of different sources such as natural gas, propane, oil or electricity in your area. Opt for a system that use a cost effective fuel based on local prices and availability. Third is system setting. Ensure that the heating system is appropriately sized for your house. An oversized system can lead to frequent cycling, which reduce efficiency. A proper size system maintain consistent comfort. The next point is maintenance. Regular maintenance is crucial for keeping any heating system operating efficiently. Choose a system which is readily available and affordable. And next slide is beyond efficiency, additional consideration. We can also consider insulation, that is proper insulating wall, ceiling and attics to minimize heat transfer. Also, air sealing, air leaks around window, door and other opening can significantly impact efficiency. Sealing these leaks help retaining warmth and reduce heating need. Renewable energy consideration. Consider integrating renewable energy sources like solar panel to power your heating system or supplement your energy needs. Next is strategies for optimizing heating system efficiency. It need regular maintenance, clean or replace air filter. A clogged filter restrict airflow, forcing the system to work harder. Replace air filter monthly during peak heating system. Inspect and clean component. A technician can identify and address any minor issue before they snowball into bigger problem. Then smart thermostat habits. Programmable thermostats are your friend. Set your thermostat to a lower temperature when you are asleep or away from home. Next is smart thermostat offer even more control. Consider upgrading a smart thermostat that can learn your heating preference and create an automatic schedule. Some model offer features like geofencing, which adjusts the temperature based on your location. Next point is seal the leaks. Like we have learned, inspect window and door for gap. Look for air leaks around your frame and can be used for weather stripping to seal them. Consider window treatment. Install thick curtain or blind on window, extra layer of insulation. Now the summary. What we have learned in this lecture so far, that is HVAC, heating, ventilation and air conditioning. It keeps us comfortable all round through a network of components including air filter, blower, heat exchanger and coils to deliver conditioned air throughout your home. Understanding the principle behind the heating, ventilation and conditioning. Energy efficiency is crucial. So consider factor like climate and fuel loss when choosing a heating system. Furnace, boiler or heat pumps each have their strength. Efficiency rating system like AFUE and SEER helps you compare option. Finally, adopting strategies like regular maintaining, use of programmable thermostat and sealing air leaks can significantly improve the efficiency of your heating system, saving your money and reduce your environmental impact. In next slide, the topics to be covered in next lecture. The topics which we will cover in next lecture is comparison of cooling option, efficiency rating and consideration for cooling system, strategies for optimizing cooling system efficiency, maintenance practice for HVAC system, control strategies for energy efficiency, zoning and ductwork optimization. Thank you.